Hello friends, welcome back to our YouTube channel. If you like this video, please like, share and subscribe. I'll share our videos commanded by our experts, so let's begin.
If you like, please like, share and subscribe. So let's begin our today's topic. Let's begin.
Imagine a towering structure built from thousands of interconnected glass rods. If the bottom pillar cracks, the entire system shatters. Enterprise AI has hit this exact bottleneck. The strategy of scaling massive, monolithic language models has reached steep diminishing returns in raw reasoning capabilities. To bypass this ceiling, engineers have resorted to hand-coding complex multi-agent pipelines to string different, highly specialized models together. These hard-coded Directed Acyclic Graphs, or DAGs, are inherently brittle. Whenever an underlying model updates or deprecates an API, the entire pipeline fails and demands immediate manual maintenance. On June 22, 2026, Sakana AI launched Fugu, a commercial orchestration platform engineered explicitly to replace these fragile pipelines. Fugu operates on system-as-a-model orchestration, internalizing multi-agent coordination as a learned foundational capability. By treating orchestration as a model, Fugu dynamically routes tasks, scales compute power, and ensures enterprise data sovereignty through a single abstraction layer. For an enterprise engineer, interacting with Fugu starts with sending a standard POST request. The platform requires no new integration frameworks. It acts entirely as a drop-in, standard OpenAI-compatible API endpoint. Beneath that single endpoint, Fugu actively analyzes the incoming payload and dynamically routes the request into one of two distinct processing pipelines. The first is the base Fugu tier, a pipeline optimized strictly for low latency and quick response speeds. This everyday corporate utility tier is tailored specifically to power standard interactive chatbots and inline programming assistants like Codex. The second pipeline is Fugu Ultra, the high-stakes enterprise flagship tier engineered for massive compute execution. Ultra coordinates a significantly deeper pool of advanced expert models to tackle intensive, multi-step tasks, including cybersecurity assessments, SWE Pro software engineering, and deep academic research. This abstraction layer removes the infrastructure burden, turning multi-step reasoning into a routine API consumption task. Instead of relying on static graphs, Fugu utilizes fluid, real-time node generation built on Sakana's Trinity and Conductor research. The system reads the runtime query demands and autonomously determines the precise subtask delegation required to execute the prompt. The workflow begins with a planner agent tasked with breaking down the primary query. Once mapped, the planner spawns a worker agent to execute the first subtask. Simultaneously, a verifier agent is attached to that worker, assigned exclusively to auditing the output. None of these roles are permanent. They are transient agents that exist only for the milliseconds required to solve this specific runtime query. By bypassing hard-coded pipelines, the system can safely process novel, unpredictable enterprise workflows without manual re-engineering. The dynamic between the worker and the verifier creates the foundation for a concept called test time scaling. In a SWE Pro software engineering task, the generated worker agent outputs a targeted code snippet. Before releasing the output, the verifier agent audits the snippet and flags a logic error. This diagram shows Fugu's autonomous response, orchestrating a recursive loop by spinning up a new worker to correct the exact error identified. This continuous validation loop cycles autonomously, adjusting the workflow prior to synthesizing the final response. This is an active architectural trade-off. Fugu trades upfront response speed, or latency, to unlock massive gains in reasoning and accuracy. The entire recursive process executes entirely under the hood, requiring zero prompt engineering or human intervention. Test time scaling takes latency, historically viewed as a strict performance flaw, and converts it into an active compute resource utilized for autonomous error correction. The infrastructure layer beneath task execution consists of the foundational models that actively populate Fugu's routing pool. A critical vulnerability in modern enterprise systems is an absolute reliance on a single frontier vendor model. This reliance exposes enterprise operations to sudden geopolitical export controls, mirroring the recent limits placed on Claude Fable 5 and Mythos Preview. This diagram illustrates Fugu's mitigation response, isolating the restricted model and automatically routing data connections around it to alternative agents within the pool. Developers retain explicit custom routing controls, allowing enterprise architects to manually opt out specific LLMs or entire cloud providers to ensure strict corporate compliance. Fugu incorporates robust data privacy options, allowing users to explicitly opt out of having enterprise prompt data utilized for future training cycles. The service does carry current geographic limitations, operating under a strict restriction from deployment within the EU and the EEA. This geofence remains active while Sakana AI formally refines its black box dynamic routing mechanics to fully comply with rigid GDPR regulations. Ultimately, dynamic learned routing elevates enterprise AI from a fragile state of single vendor dependency to a secure state of algorithmic sovereignty. Stripping away the internal mechanics of routing and recursion leaves only that single, simple API endpoint. Fugu forces a structural shift, moving the industry away from infrastructure construction and toward pure infrastructure consumption. Consolidating multi-agent coordination into a learned model removes the overhead of managing brittle DAG pipelines. Simultaneously, this abstraction layer neutralizes algorithmic lock-in, actively shielding enterprise architecture from external export controls. As enterprise workloads evolve, operations are rapidly moving from isolated chatbot prompts toward fully autonomous, multi-step execution. This illustrates emergent order, where independent agents synchronize into a single, cohesive unit to resolve the user's query. As enterprise workloads scale in complexity, system-as-a-model architectures provide the technical framework for the next generation of industry integration. If you've ever tried to wire together a dozen specialized AI agents from scratch, you know the headache. You're writing custom logic for every handoff, debugging endless routing loops, and praying the pipeline doesn't shatter when an API updates. Sakana AI built Fugu to solve exactly this problem. Instead of managing a sprawling architecture, you pass your request to a single API, and Fugu orchestrates a collaborative ecosystem of AI models for you. To set this up, you'll need three things: a standard Python environment, the OpenAI SDK already installed, and an active Sakana API key. A quick check before we start. Sakana is currently refining their black box routing to meet GDPR standards. Because of this, Fugu is restricted from operating within the EU and the EEA right now. Collapsing the orchestration layer into a single endpoint means your code doesn't have to change even as the underlying network of models grows more complex. You interact with a specialized ecosystem, exactly as you would a single model. Step 1. Log in to the Sakana developer portal, navigate to your credentials, and generate your unique API key. While you're still on the dashboard, look at your account settings and flip the Data Privacy Opt-out toggle to the active position. Activating this setting guarantees any proprietary code or sensitive strategy you pass into the system is entirely excluded from Sakana's future training cycles. Establishing absolute data privacy at the authentication layer allows you to route enterprise-grade AI workflows without risking intellectual property leaks. Now, open your existing Python script, the one currently using the standard OpenAI client. Look for your client initialization. All you have to do is change the base URL parameter from the OpenAI endpoint to api.sakana.ai/v1. This visualizes Sakana's system-as-a-model architecture. Your code acts like it sends a request to one server. You don't specify who is the planner or worker. Fugu handles that automatically. It instantly splits the workload, assigning subtasks to a planner, worker, and verifier on the fly. Because this routing intelligence lives entirely inside the endpoint itself, you can utilize complex orchestration without maintaining proprietary software development kits. Next, scroll down to your API request payload and locate the model parameter string. Sakana offers two tiers here. The standard Fugu model prioritizes low latency, making it the right fit for interactive chatbots and everyday coding assistants. Fugu Ultra is the flagship tier, designed to tackle deep research tasks like software engineering or cybersecurity. Since we are building a rigorous multi-step pipeline today, type Fugu Ultra directly into the model field. Now we need to address potential vendor restrictions. Sometimes specific models in an ecosystem get hit with sudden export controls or regional blocks. To protect your pipeline, you can explicitly dictate the models Fugu is allowed to use, add a custom routing pool block to your payload, and explicitly exclude Claude Fable 5. If a vendor abruptly restricts access, this exclusion ensures Fugu will automatically swap in a different capable agent instead of allowing the workflow to fail. These granular routing pools allow you to build resilient, globally compliant ecosystems without rewriting any of your underlying application logic. Save your file, open your terminal, and run the script. You will notice that the prompt hangs for a moment. The response takes noticeably longer to generate than a standard single-model query. That latency is the result of test time scaling occurring behind the scenes. The system uses this window to call itself recursively. It corrects workflow deviations and validates its own logic before data is returned to you. This console output shows a fully vetted, multi-step execution. Sacrificing immediate response speed for this level of internal validation ensures the system provides a verified solution rather than just a quick prediction. You just turned a basic prompt into a highly validated multi-step output, and you achieved this by dynamically leveraging a pool of AI experts while maintaining absolute corporate data sovereignty. To see the difference in depth, go back into your code, swap the model to the standard Fugu tier, and run the script again to compare the latency metrics. True scalability lies in orchestrated systems rather than larger individual models. Check the video description below for the exact code snippets we used today, and start building.